today's video, we are going to cover section 10.2, congruent chords. After studying this section, you'll be able to apply the relationship between congruent chords of a circle. Looking at my diagram to the right, we can see that we have two chords that are the same distance from the center. We can conclude two theorems based off this diagram. The first being, if two chords of a circle are equidistant from the center, then they're congruent. What this is telling me is, if I have xp congruent to py, then AB will be congruent to CD. This is because if I draw in my radii AP, DP, CP, and BP, I'm creating four separate congruent triangles. Then AX, XB, CY, and YD would all be congruent. I could add AX and XB to make AB, and CY and YD to make CD. Therefore, AB would be congruent to CD. So, Theorem 77, if two chords of a circle are equidistant from the center, then they are congruent. Now, the converse of this theorem, if two chords of a circle are congruent, then they're equidistant from the center of the circle. So, if I have CD congruent to AB, then FO will be congruent to OE. I could do the same thing to prove this theorem that I just did for the last theorem. Now looking at our sample problems, we're given circle O. I'm given AB congruent to CD. OP is 12x minus 5. OQ is 4x plus 19. I want to find OP. So again, I have congruent chords here, AB congruent to CD. That tells me that OP will be congruent to OQ. If OP is congruent to OQ, I'd have 12x minus 5 is equal to 4x plus 19. Solving this, I would add 5 and subtract 4x to get me 8x is equal to 24. I divide by 8 to get me x is equal to 3. Plugging that back into OP, I would have 12 times 3, which is 36, minus 5, which is 31. So the length of OP is 31 units. Looking at our last problem, problem 2, we're given triangle ABC as isosceles with base AC, circle P, PQ is perpendicular to AB, and PR is perpendicular to CB. We want to prove triangle PQR is isosceles. So in order to prove triangle PQR is isosceles, we need to show that PQ is congruent to PR, or angle PRQ is angle to PQR. Now looking at our givens, we have ABC as isosceles with base AC. That would tell me that sides AB and BC are congruent, as well as angles C and angles A are congruent. Now, if AB is congruent to CB, the theorems that we just learned, if I have congruent chords, then they're both equidistant from the center of the circle. I can see that PQ and PR would then be congruent because they are the perpendicular segment with AB and CB. So I would now have PQR as isosceles because if I have two congruent legs, then I would have an isosceles triangle. So looking at this in my statements and reasons, I'd have my givens. Then I would have that AB is congruent to BC because an isosceles triangle has two congruent sides. Now PQ is congruent to PR because if two chords of a circle are congruent, then they're equidistant from the center. And I can say that PQR is isosceles because a triangle with two congruent sides is isosceles. In today's lesson, we learned congruent chords are equidistant from the center of the circle. That's a wrap on today's video. We'll see you in the next one.